Okay, Year 10. The next exercise in Desmos is the circle. This is going to be very hard because it's going to be hard for me to freehand draw a circle. I might be able to use the shapes, but we'll see how we go. The first thing we have to work out or use is that our standard circle at the origin. Well, a standard circle at the origin can be written like that. So I'm going to shoot over here to Desmos. And if we write, okay, so x squared plus y squared equals 9. And there's a circle, the centre at the origin, and a radius of 3. So let's go back and have a look. So if it's written as x squared plus y squared equals r squared, all right, you have to square root that number that's here to get the radius. So whatever number is there, that's going to give you the radius when you square root it. So this one here, it's a nice easy one. Let's see if I can get a circle. Let's see. Oh, look at that. There you go. So there's a circle. Its centre is at the origin, and its radius is the square root of 4. And remember, when we square root, we get two numbers. We get plus and minus 4. But because we're talking about a distance, it's just going to be the positive. And the square root of 4 equals 2. So this circle, centre at 0, 0, radius of 2. This one, well, we just drew back there with Desmos. There it is. The radius is 3. So when you go over here, and you're going to sketch this one, again, let's see if we can get this. I want it to be a bit bigger than the other one, and let's move it. There you go. This is going to be a lot easier than I thought. So this time, the radius is the square root of 9, and that equals 3. So we've got 3, 3, -3, and -3. Now, the first thing you need to be asking yourself is, well, is this a function? And it's not. This is not a function. I'm going to move this because I'm not happy about that. Where is it? Can I get it up? I don't think I can. Let's draw another one. Come on. Why is that all wobbly? All right. Yeah, it's not a function. Well, that's hopeless too. I'll go over here and draw one. Maybe it was because it was getting all the things on it. Oops. Okay, let's move it. There you go. It's not a function because it doesn't pass the vertical line test. So when you're doing this and you're going, oh, I run a vertical line, I'm going to hit it twice. So it's not a function. Let's have a look at these ones though. We can make it a function. Now, if I take the positive square root, so let's take, for example, let's square both sides because this is an equation. So if I square both sides, I'm going to get y squared, and if I square a square root, I just get whatever is under it. So I get y squared equals 4 minus x squared. And if I take that x squared over the other side, x squared plus y squared equals 4. But by saying that this is a square root, I'm saying you only want the positive part. So essentially, this function here, or this relation, or these two things, are exactly the same, but because that square root sign is there, It's only the positive part. Only the positive part. So I'm going to have to freehand this one. This one is a circle. Oh, that's awful. This one is a circle. I wonder if there are semicircles up there. No. This one is a circle. Same as the one above, radius of 2, but because I'm taking the square root and the positive square root, it's only the top half. And it does touch the x-axis. This one is exactly the same as the one above, except it's because it's got a negative out the front, it's the bottom half of that. So, I knew this would be hard. It's the bottom half. That'll do. It's the bottom half of this circle. So -3, 3, and -3. All right, so they're your standard ones. And I'll just show you on Desmos how it works. So if you were to square root this, so we'll get rid of that. Or let's just change that 9. Let's just change that 9 to an R. And we're going to square that R, add a slider, and watch what happens. Why can't I play that slider? Let's go, I don't know, 16, -16, -16 to 16. Why isn't it moving? Why can't I play it? Add a slider R. It's not letting me play it. But if you move that, you just get a bigger or smaller radius. So let's go back now and have a look at this. And oh, by the way, you can draw a semicircle on Desmos. All you have to do is you've got to know your indices laws. And if I go y equals, now you can get a square root, I'm pretty sure. Oops, sorry. If I just go the next one, and the next one, I thought you could get a square root sign. You can get an absolute value, but you can't get a square root sign. You can write the square root. I'm sure you're able to get it. But if you know your indices laws, you're going to write y equals bracket we'll make it r squared. That's probably why it wouldn't let me do the slider. And if I raise that to the power of a half, righto? And you can see that it's a semicircle. And if I put a negative in front of it, it's the bottom half. So there's our semicircles. Now these two here are functions. How do we draw these other two, the last two? Oh no, there's that one there. Don't worry about that one. I'm going to let that one go. I'll continue with it on the video, but you don't have to do it. Well, when we write it in this form, all right, we're writing it like this, where h and k. So the radius still stays, but now we're transforming it. Now, this is the whole key with this whole elective. When we do functions and relations, if you put something with the y, it moves it up and down. If you put something with the x, it moves it left or right. Let's just demonstrate that on Desmos. So we'll write that exact equation. So x squared plus, oh no, I've got to put in brackets. So x minus h all squared plus y minus k all, all squared equals r squared. It must be because I've got that r and it's by itself. So here, look at that circle. I'm just moving the h and it's moving it left and right. Now if I pause it there, and if I just move the k, that just moves it up or down. And that's moving the centre, that h and k are representing the centre of the circle. So let's go back here. This one is a centre of a circle, and to work out where that centre is, you have to look at that and go, oh, what's going to make that equal 0? What value of x is going to make that equal 0? And it's an x value of 2. So 1, 2. It's moved it 2 to the right. And this one here has moved it 3. Now what value of y is going to make that equal 0? And it's -3. So it's moved it 3 down. 1, 2, 3. And I think in the Desmos book solutions, I've actually got this incorrect. So there's my new centre of this circle, right? So let's see if this works again. And we'll move this down here. And I'll just make that. Because this circle, come on, just touches the x-axis, because the radius is a square root of 4 is 2. So it's here 3, it's got to go down to 1 and across 2. So this circle, if I was able to extend these axes or use a different scale, just touches the x-axis, because its centre is 2, -3, and it's going to touch there at y equals -3. Oh, -3. 1, 2, and it should be the same distance there. That's a really bad diagram. I'm going to quickly do that again. So 1, 2, 1, 2, 3. There's the centre. Draw your circle. Oh, that's much better. It's possibly a bit bigger that way. A bit bigger that way. That's it. Now, so my centre of my circle is 2 and -3. It touches here at -1, -2, -3. This is 1, this is 2, and it should really be going all the way up to there. That's a much better one. Righto, this is the last one. This is the hardest one you're going to get. By the way, don't have a go at that one. I'm going to do it in a minute, but I don't expect anyone to be able to do it. So this one, it's another circle. The radius is a square root of 9. So the radius is 3. The centre of the circle, well, what makes that equal 0? 1. So it's at x equals 1. So it's moved to the right 1. What makes that equal 0? -2. It's moved down 2. 1, 2. So it's there. But the radius is 3. So let's draw it. Now, it's going to hit the axes at different spots. All right? It's possibly, if I could get it back, no, I can't. I need a bigger circle because I want the axes to be accurate. Yeah, that's more like it. That's more like it. So here's my center, and it's at 1, -2. By the way, I'm pretty sure in the booklet I messed that up. I changed that to a -3, which moved the whole circle up to there. So if you're looking at the Desmos solutions, that's what you'll see. Now, if you want to get full marks for this, you need to find these points. That one, that one, that one, and that one. They're the x and y intercepts. Now here's where you need to develop a little bit of algebra. So how do I find the y intercepts? I let x equal 0. So 0 minus 1 squared plus y plus 2 squared equals 9. Oh, that's -1 squared plus y plus 2 squared equals 9. That's 1 plus y plus 2 squared equals 9. Subtract the 1, y plus 2 squared equals 8. Square root both sides, y plus 2 equals plus or minus root 8, and minus the 2, y equals -2 plus or minus root 8. Now you can work that out as a decimal. I'm going to do that in a minute. But think about this. That's telling you that, let's go green, that here's y equals -2. There's y equals -2. That distance is root 8. So that's -2 plus root 8. And that distance is root 8. That's -2 minus root 8. Now, if we work those out as decimals, -2 plus root 8, 0.84. So equals 0.84. And if I go back to my calculator and just change that to a minus sign, oh, bugger. So -2 minus root 8. Negative, so this is -4.8. So there's the y-intercepts. To find the x-intercepts, I'm going to let the x-intercepts, I'm going to let y equals 0. So then I get x minus 1 squared plus y0 plus 2 squared equals 9. X minus 1 squared equals plus 2 squared equals 9. X minus 1 squared plus 4 equals 9. Subtract the 4, x minus 1 squared equals 5. Square root both sides, x minus 1 equals plus or minus root 5. Add the 1, x equals 1 plus or minus root 5. And exactly the same thing happens. Look here, there's x equals 1. This root is 1 plus root 5. And this root is 1 minus root 5. And again, with your calculator, 1 plus root 5, 3.23, and minus, let's see if I can do it this time without stuffing it up, negative 1.23. Negative 1.23. Now, that's as hard as we're going to get. We're going to shift it, but if you get in your head that putting something with the X and putting something with the Y shifts it left or right, you're away. Let's double check on Desmos to make sure that's exactly right. So we'll go here. X minus 1 all squared plus, okay. So X minus, oh, come on, back here. Oh, get out of there. Let's move that to H is 1. Let's make R 3. Come on. And let's make K. K was 2, so we have to make, I want that to be 1. Oh, this is so finicky. And that's negative 2. Come on. Oh, get out. Right. Now, if I click over here, what's that? 3.23, negative 1.23. There's that. There's that. And are they the same as what we got? Yes, they are. Okay. If you're happy with that and you can do that and you can shift it up and down, you can get those circles, great. I'm going to do this one, but realize that this is not going to exist in any of your tests or any of your work, but it's good to be able to do it. Some of the 5.3 students should be willing to give this a crack. So what do I need to do here? This is not in the form that I would like. I need it to be written as x minus h all squared plus y minus k all squared equals r squared. So here we go. I'm going to rewrite this x squared minus 6x plus 4 y squared plus 4y equals 3. Oh, but look at the big gaps you've left. All the better for completing the square, my young Padawans. So to complete the square, I halve that and square it. So half of 6 is 3 squared is 9. I'll do the same here. Half of 4 is 2. 2 squared is 4, so add 4. And whatever I do to the left-hand side of an equation, I must do to the right-hand side. And now I can rewrite these as x minus 3 all squared plus y plus 2 all squared equals 16. Beautiful. This is going to be a circle, radius. What makes that equal 0? X equals 3. What makes that equal 0? Y equals minus 2. So this is going to be a circle at 3, 2. X equals 3. So let's make this bigger. 1, 2, 3. And y equals minus 2. 1, 2. Let's get a circle here. And the radius is 4. So it has to be a pretty big one. And that'll do. Now, we have to find where it cuts the x and y axes. Excuse me. So we've got our centre, which is 3 and negative 2. And we need to find the intercepts. So I'm going to let x equals 0, and I get 0 minus 3 squared plus y plus 2 squared equals 16. 9 plus y plus 2 squared equals 16. I'm going to go really fast now. Add that, so subtract the 9, y plus 2 squared equals 16 minus 9 is 7. Square root it, y plus 2 equals plus or minus root 7. So y equals negative 2 plus or minus root 7. That looks like a 2. Let's fix that up. So when x is 0, y equals minus 2 plus root 7. So this one is minus 2 plus, this one. Minus 2 plus root 7. And this one is minus 2 minus root 7. Okay, let's get the x-intercepts, and you can find out what they are as a decimal. The x-intercepts, let y equals 0, and I get x minus 3 all squared plus y 0 plus 2 all squared equals 16. X minus 3 all squared plus 4 equals 16. X minus 3 all squared equals 12. X minus 3 equals plus or minus root 12. X equals 3 plus or minus root 12. Over here, this one, 3 plus root 12 and 3 minus root 12. And you can work those out as decimals. I'm not going to ask you anything as hard as that because the algebra there, we don't do completing the square. We don't do it. 5.3 students should be able to do it. But this one, yes, and knowing that if I change the value with the x, it moves it left and right. If I change the value with the k, come on, play for me. It changes, it moves it up or down. Why isn't that? Come on. So it moves it up or down. All right, good luck with that. And that's the last bit that we have to do before the end of term.